So our last few lessons have been about surface area. Now we're going to make a jump to volume. Today we're talking about the volume of prisms and cylinders, and the formula is pretty general and basic, and it works for all prisms and cylinders. All you got to do is take the base area and multiply it by the height or the altitude of the figure, and you'll have the volume. You've known this since probably 5th grade. You know the volume of a rectangular prism was length times width times height. Well, that's because the area of the base is a rectangle, and it's length times width. And then all you got to do is multiply by the height. Now, you might be wondering, why are you calling it altitude? The reason I call it altitude is because triangular prisms have a different kind of base. They have a triangular base, and that triangle has height. So I'm trying to avoid confusion between the height of a triangle and the height of the prism. Not that it makes any difference, because if you transpose the numbers, it's going to work out to be the same value anyway. But I just, for myself, like to keep them straight. The triangle has height and the prism has height. And the height of the prism I'm calling altitude. Now a cylinder, same basic idea. You find the area of the base, you multiply by the height or the altitude. Your base for a cylinder, though, is going to be pi r squared. But same basic idea. So take a moment and see if you can find the volume of these two figures. I always start with the general formula, base area times altitude. Then I figure, okay, what kind of base do I have? In this figure, I got a rectangular base, so that's going to be length times width times altitude. The only thing that's going to change in your formulas is what kind of base you have. How about this figure? It's a trapezoidal prism, so the base area is going to be given by the area of a trapezoid. Do you remember the area formula for a trapezoid? It's the average of the bases times the height, or 1/2 b1 plus b2 times h. So b1 and b2, remember, have to be parallel to each other, so your bases are going to be 5 and 11, and the height between them is going to be 4, and then the altitude of the prism is going to be 8. That's the distance between the bases. So you should have come up with 256. Now why don't you give this cylinder a try? The general formula is base area times altitude. Your base area is going to be a circle, so it's pi r squared. Looks like the diameter is 8, so the radius will be 4. And the altitude of the prism is 9. Pretty simple. Estimate 452. It's often the easiest problems that'll stump students. These are examples. This is why I teach you the general formula, because it's just base area times altitude. You don't even have to figure out the area of the base. It's given. The area of the base is 40 square units. A much harder problem, next time I'm going to have you find the area of the base for the hexagon. But here it's given. But you'd be surprised on quizzes and tests, people get stumped by this. Now, on this one, does it matter that the prism is oblique, that it's leaning to the side? No. As long as the base hasn't changed and the altitude hasn't changed, then the volume's not going to change. The surface area gets a lot bigger, but oblique prisms have no effect on volume. So the volume's going to be the same. Pause the video here and try this one. You could think of this as two separate prisms. You got a square prism on the bottom and a triangular prism on the top. Or what you could do is just find the area of the base altogether. Think of it as a square with a triangle on top. And once you find the area of that base, then you just multiply by the altitude, which would be 10. So we know the height of the triangle is going to be 3. So it looks like the base area is going to be 45. And the altitude of the prism we know is 10. So you're looking at 450 cubic units. So this one looks like it's much more complex, but really it's not too bad. It's a composite figure. You got a rectangular prism on the bottom with a hexagonal prism on top. And the hexagonal prism isn't even that difficult because, again, I've given you the base area. So let's start with the prism on the bottom. The base area is length times width, which is going to be 8 by 8, and the altitude's 3, so that's 192 cubic units. The hexagon on the top, the area of the base is 40, the height 7, or the altitude 7. That's 280 cubic units. You add it together. Pretty simple. Okay, so for this last problem, we're going to find the volume of this pipe. It's obviously an outer cylinder minus an inner cylinder. Base area times altitude. The base is pi r squared. Looks like the radius of the outer circle is going to be 7. So that's 1470 pi. The inner circle has a radius of 6. So that's going to be 1080 pi. We subtract those, we end up with 390 pi, which is approximately 1224.6. And this is a bit of a paradox, isn't it? All right, have a great day. Talk to you tomorrow.